All right, chapter 7, section 3, proving that quadrilateral is a parallelogram. We're just doing the converse, meaning the opposite of 7-2. Okay, so we're switching the if and then statement. So looking at this one, it says parallelogram, opposite sides, converse. So parallelogram, opposite sides theorem stated, if it's a parallelogram, then both pairs of opposite sides of a quadrilateral are congruent. So we're switching it. This is the converse. So again, if both pairs, key thing here, it has to be both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so again, it has to be both pairs. So I'm going to go ahead and write the statement. So looking at this, if I were to write it as a statement, it would be if AB, segment AB is congruent to segment DC or CD, and BC is congruent to AD, then ABCD is a parallelogram. Again, this is the converse of what we did before. Okay, so 7-2, we did not switch them. It was already telling me that it was a parallelogram. All right, parallelogram, opposite angles, converse. So if both pairs, again, both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I'm going to go ahead and write this one out. If it was giving me a statement, it would be if angle B is congruent to angle D and angle A is congruent to angle C, then ABCD, quadrilateral ABCD, is a parallelogram. Again, we are looking at converse of what we covered yesterday. All right, opposite sides, parallel and congruent theorem. Okay, pay attention to this one. If one pair of opposite sides of a quadrilateral are congruent and parallel, it has to be both congruent and parallel, then the quadrilateral is a parallelogram. Keep in mind that one pair, okay, it has to be the same pair, The same pair have to be both congruent and parallel. What can it not be? I'm going to give you an example of what it cannot be. Okay, so looking right here, if I'm giving you a parallelogram, keep in mind when I said same pair, these are not same pairs, congruent and parallel. They're different pairs. One pair is parallel, one pair, a different pair, is congruent. It has to be the same pair. So this is what it cannot look like. Okay, it has to be the same pair. So when I'm looking at this one, it's the same pair that's parallel and congruent. So make sure you have that. So writing out a statement. If BC is parallel to AD and BC is congruent to segment AD, then ABCD is a parallelogram. So again, it has to be the same pair, okay? One pair of opposite sides, it has to be the same pair. All right, parallelogram, diagonals, converse. Again, we're looking at the converse of something. If the diagonals of a quadrilateral bisect each other, so they're telling me they bisect each other, then I know the quadrilateral is a parallelogram. So again, if they were to give it to me as a statement, what would it look like? There are two ways that this could be written. The first one is if BC it's BD. If BD and AC bisect each other, then ABCD is a parallelogram. Or it could be written as if BD, or not BD, I'm going to go ahead and put an E right here in the middle. If BE is congruent to ED and AE is congruent to EC, then quadrilateral ABCD is a parallelogram. Okay, those are the two ways they could be written. All right, 5 ways to prove that a quadrilateral is a parallelogram. These are all the ones that we kind of just went over. However, shows that both pairs of opposite sides are parallel. That's the definition of a parallelogram. You cannot forget that one. Please remember the difference between the definitions and the theorems. Okay, show that both pairs of opposite sides are congruent. Shows that one pair of sides are parallel and congruent. Shows that both pairs of opposite angles are congruent, and shows the diagonals bisect each other. So this is them looking in words. I understand that some of us are more visual. So if you go to the next slide, it gives you the diagrams. Keep in mind, look at the difference between one and then the rest of them. One says definition. Shows that both pairs of opposite sides are parallel. Again, this one is the definition of a parallelogram. Do not get that mixed up. A lot of students get this one mixed up with the second one. It says, shows that both pairs of opposite sides are congruent. Keep in mind, this one says congruent, this one says parallel. If they're parallel, it's definition. If it says that they're congruent, this is opposite sides, parallelogram, opposite sides, converse. Okay, sides are congruent, and if you're looking at the next one, angles are congruent. This is parallelogram, opposite, angles, converse. Forgot my E. Looking at the next one, shows that one pair of opposite sides are congruent and parallel. Okay, congruent and parallel, so it has to have congruent and parallel. This one is opposite sides I'm dealing with my sides, parallel and congruent theorem. And then the last one shows the diagonals bisect each other. This is parallelogram, diagonals, converse. Oh, I forgot my O. Okay, so visually this is all of them. Please make sure you know the difference and you remember these. You will see these again and you'll eventually use these for theorems. All right, looking at example number 1, it says state the principal definition or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. So they want me to look at these and determine which definition or theorem am I using for these. So looking at the first one, I'm going to go ahead and do them all in different colors so we're not getting confused on my markings. So if I'm looking at the first one says segment BE is congruent to segment ED and segment CE is congruent to EA. So here's BE, it's congruent to ED. Here's CE and it's congruent to EA. Which definition or theorem are we using for this? Yeah. Good. Diagonals. I'm looking at my diagonals. That one should definitely be one of the easiest ones. So I'm going to write it, and I'm going to write the definition. Just the more we write it, the more hopefully we remember it. It's parallelogram, diagonals, converse. Okay, and what does that mean? If, I'm going to zoom in, diagonals of a quadrilateral, I'm just going to put quad, bisect each other, then the quadrilateral is a parallelogram. Okay, so I'm just writing the definition there so we have it. Looking at the next one, it says angle BAD, which is right here, is congruent to angle DCB, and angle DADC, which is right here, is congruent to angle CBA. So which one am I using for that? Okay, I'm looking at my angles. Yeah. Good, I'm dealing with opposite angles. So I'm going to write it as parallelogram, opposite angles, converse. You're telling me that my opposite angles are congruent. So writing out this definition, what does this mean? If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. All right, looking at the next one, it says BC is parallel to AD. So BC is right here. Drawing my parallel symbol, my arrow. It's parallel to AD. And AB is parallel to DC, okay? Keep in mind now we're dealing with parallel, okay? Opposite sides are parallel. Which one is this? Again, don't get this confused with a different one. Which one's this? Where it's telling me my opposite sides are parallel, okay? Which one would this be? If you need to look back, go ahead. Jonah? Good. This one is definition of a parallelogram. Please don't get this one confused. This is definition of a parallelogram. Okay, it's telling me that my opposite sides are parallel. Okay, opposite sides are parallel is definition of a parallelogram. Now, look at the next one. If we're looking at the next one, it's giving me BC is congruent to AD and AB is congruent to DC. Look at the difference between definition of parallelogram and the next one. BC is congruent to AD, so I'm doing that in orange. And BA or AB is congruent to CD. Now I'm saying that opposite sides are congruent. Which one should this be? I'm dealing with congruency, yeah. Opposites, good. Opposite sides, converse, okay? Parallelogram, opposite sides. And don't forget this is converse. Okay, so writing the definition for this one so we have it. This one is, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Okay, so there's a difference between your sides being congruent and your sides being parallel. Please do not get those two mixed up. Okay, make sure you know the difference between those two. And then looking at the last one says segment BC is parallel to AD. Okay, so drawing my parallel signs. I'm only looking at BC and AD. They're parallel and they're congruent. They're parallel and congruent, and I'm only looking at one pair of sides, the same side. So which one should 5 be? Which one should this be? Yeah.
Opposite sides, congruent and parallel.
Good. Okay, so this one is opposite sides. Parallel and congruent theorem. And stating what this one is, this one states if one pair of opposite sides are congruent, I'm just going to use my signs, and parallel. Keep in mind it's the same side. Okay, the same side. The same pair of opposite sides have to be parallel and congruent. Then the quadrilateral is a parallelogram. Okay, these are always to prove that a quadrilateral is a parallelogram. So please do not get them mixed up. There are a lot of colors here and symbols. So please remember what goes with what. All right, looking at example number 2, it says, for what values of x and y is quadrilateral PQRS a parallelogram? So which theorem do you think I'm using for this? Yeah. Okay, good. Opposite sides converse, that's saying my opposite sides are congruent. Okay, so parallelogram, opposite sides. This side is congruent to this side. This side is congruent to this side. Which side do you think I'm going to solve first? Or which one is, yes?
Top and bottom.
Top and bottom. Why can't I do side to side?
Because there's a y and x on side to side, and first you have to solve for x.
Good. So because PS and QR both have an x and a y, I need to solve for one variable first. So I'm going to do PQ is equal to SR first, so I can solve my x. So writing it out, I'm going to have x plus 9 equals 2x minus 1. I'm going to solve for x. So this is algebra. X plus 10 equals 2x. Subtract x from both sides. 10 equals x. That one was a pretty easy one. All right, so now that I know that information, I'm going to go ahead and now solve for my other side, plugging in my x. So I'm solving for PS is equal to QR. And I have y equals x plus 7. What am I plugging in? I'm plugging in this x for x right here. So I'm going to have y equals 10 plus 7. If you solved it correctly, y should equal 17. So now we know our answers for both of these. X is 10 and y is 17. All right, similar question, except I'm looking and I have angles. Which one am I using for this? Which theorem would I use? Yeah. Good, opposite sides. Okay. Or angles, thank you. Parallelogram opposite angles, converse. Okay, so if I'm looking at these, which angles are congruent? Which angles are congruent? A is congruent with what? Good. Angle A is congruent with angle C. So then that means angle B is congruent with angle D. Does it matter which one I solve first for this? No, because my x's are together and my y's are together. I'm not mixing my variables. So setting them equal, I'm going to go ahead and do B and D first. So angle B is congruent to angle D. So I'm going to have 4y equals y plus 87. I'm going to subtract y from both sides. 3y equals 87, divide by 3. And y is going to equal 29. And then solving for the other angles, angle A is congruent to angle C. 3x minus 32 equals 2x. Subtract 3x from both sides. Negative 32 equals negative x. I can't have a negative x, so I'm going to put a 1 in front of my x. I have negative 1. So I'm dividing both sides by negative 1. X is going to equal 32. So I have my answers here. X is 32 and y is 29. And then looking at the last slide, it is a proof. It says write a 2-column proof. So that's the first thing that I should do. Here is my 2-column proof. I have my statements and my reasons. And they're saying, given angle ADB is congruent to angle CBD, and angle ABD is congruent to angle CD. Well, the first one was CBD. Now this one's CDB. A lot of letters. Okay, looking at it, the first one is always what they're giving me. So I'm going to go ahead and write angle ADB is congruent to angle CBD, and angle ABD is congruent to angle CDB. And that's given. Okay, most important thing is to also draw what's on the diagram, and it is drawn for us. Second thing, I'm going to look at the diagram. Looking at the diagram, what does it look like they're giving me? What does this look like? We kind of covered this in previous lessons, chapters, yeah.
Maybe you're sharing this side.
Okay. Okay, but I'm not trying to split it into a triangle. I'm trying to prove that it's a parallelogram. So, yeah, the side is reflecting each other, but I don't necessarily need the reflection. Yeah?
It's symmetric.
Okay. But I can't say that it's symmetric. I don't see anything that's symmetric. Yeah.
Alternate interior.
Okay, good. They look like alternate interior angles. However, what do we need in order for it to be alternate interior angles? So whenever we know alternate interior angles, we know it as if I have parallel lines cut by a transversal, then your alternate interior angles are congruent, correct? However, they're giving it to me backwards. They're saying I have congruent angles and a transversal. So what is that saying about my lines? That's telling me that my lines are going to be parallel. Okay, so I can go ahead and state that what is going to be parallel. Okay, so looking at my next statement, I can say AD is parallel to BC. Okay, I could also look at it this way too. I have parallel lines cut by a transversal. So that's making these lines parallel. So again, I can also say AB is parallel to DC. And how do I know that? It's because alternate interior angles converse. All right, now if I'm looking at this diagram, I'm going to erase some of my drawings just so it looks a little better. If I were to erase all of this, I see that I have parallel lines. How could I prove that this is a parallelogram? Can I prove that this is a parallelogram from here on? Yes, using what?
Definition of parallelogram.
Good. Okay, what I just drew. If I have opposite sides are parallel, then that's definition of parallelogram. So I can go ahead and state step 3. A, B, C, D is a parallelogram. How do I know that? Definition of a parallelogram, and I'm going to write what the definition of a parallelogram is so we know what that is. If both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. Okay, so that's what it means. So this is a short proof.